I'm going to be taking you through how we're using machine learning in our project. Maybe for the stats, take you through a highlight of our project. Our project is traffic monitoring and navigation. Our problem statement is here just mainly to deal with the uncertainties that we face on the road as we are traveling that cause traffic. We know that there are very many causes of traffic. So this is going to help us to deal with those, help people navigate the road through traffic, to help them generate alternative routes that are better, that have less traffic. So the solution that we are offering is we're going to develop a model that's able to judge between models and know that judge between roads and know that this road has a better traffic has more traffic than this one. And how we are doing that is maybe using the number of cars on the road to do this. So the merits of this project is that it's going to help save users time, reduce on traffic on the road, and very many advantages that come to it. So maybe diving into the assignment of how we're using machine learning into this. So to start with, machine learning is a set of computer algorithms. They learn from data to predict patterns and outcomes and structures. So you feed the algorithm with data and uses this data to make predictions from it or to generate patterns from that data that you're given to it. It learns from this data, as we're going to look at the various learning methods that it can use. How we are using machine learning in our project, first of all, we have to train our model to be able to know what a car looks like, to be able to judge roads that have many cars or plenty of traffic, and to be able to recommend the most efficient route or the most relevant route to be used. So spoke about how the forms of learning that are used in machine learning. First, we have supervised learning. In supervised learning, the model or algorithm is fed with a labeled data set and uses that labeled data set to make predictions for any input that it will receive. So it will learn from the data that it has been given, the labeled data that has been given, say XY. So in case it receives an input X, it will know that has a corresponding output Y. Some of the examples that use supervised learning, we have spam emails, sentiment analysis. In sentiment analysis, this deals with mainly social media, where they keep track of your likes, things that you like, things you interact with more often. It's mainly used by advertising platforms to know your likes and to know the product to give you. So in spam emails, this we see it in our Gmail. We keep the emails we keep sending to your spam. After some time, the Gmail will be able to know which emails are spams and which emails are not spam. So it will automatically send those emails that look like spams to the spam section. So in supervised learning, we have regression and classification as the methods used in supervised learning. In regression, mainly we map our data and generate a line of best fit. Now this line is used to map, let's say, corresponding inputs for data. So after mapping this line, we use that line to make predictions from it. So in classification, mainly we also map our data, maybe just a zoom in to it. We map our data and then we try generating a line or curve that separates the data, similar data. So we try to know the best line that can separate similar data together. So that's to deal with classification. So mainly to go back to our project a little bit, we are going to use supervised learning. This is the best alternative, as we see. Since unsupervised learning, talk about it, it's a machine learning paradigm where our model is fed with unlabeled data set, and we just feed it with data, and then it uses that data to generate patterns and structures from it. to make predictions. So for it, it's just given data, and then it uses that data that's given to make structures and predictions from it. We're going to have things like clustering and association. These are the methods used in unsupervised learning. I'm going to focus mainly on clustering, since it's what's the most suitable option that we have to use for our project. Mainly, so what's clustering? Clustering is mainly grouping similar data points together. So if remember, we feed it with an unlabeled data set, so it groups similar data that looks alike together in clusters. So maybe how we applying clustering in our work that we shall be doing, we shall need a grouping or clustering of roads with a lot of traffic, moderate traffic, and then little or no traffic, so that our model is able to distinguish that this road has high traffic, this road has moderate traffic, this is how a road with zero traffic looks like, so that it will be able to judge when presented a road that, oh, this road falls under this category, this road falls under this category, and be able to recommend accordingly. That's how we intend to use it in our model. So maybe if I could talk about reinforcement learning also as a learning method, in this the paradigm or algorithm, it learns from its own experiences and interactions with the environment that it will be having. So it continuously has interactions with the environment and learns from them. And in this, it involves the method of punishment and reward. So for every right move it makes, or right prediction it makes, it gets a reward. For every wrong movement it makes, it gets a punishment. So for instance, examples we have is game playing and robotics. In game playing we have chess. For chess, I can say, let's say, a reward, it may win the game, and the punishment, it may be losing the game for doing a wrong mistake for it. So if we're to compare all those methods for our comparative, as I had said earlier, unsupervised learning would be the best solution that we may have, since our data that we have is unlabeled and we are aiming at discovering patterns on it. So for our case study is that maybe a user inputs coordinates of the places that they want. So we capture the image of the place of the road. We capture the image of the road the user wants to use, and we compare it with the clustered images that we have in the model that we trained. We used the concept of clustering, so it knows which road has high traffic, low traffic, moderate traffic. So we will be able to use that image to know where that road falls. So if there are many cars in that image of the road, it will fall under high traffic, and it will show there that this road has high traffic. And we shall also check for the alternative road image and see if there is high traffic or low traffic. If we compare the traffic and see that there are less cars than this, the recommended road will be the road that has least number of cars. So that's maybe a user case scenario that I can think of. The expectations that we have from this model is it has to be able to predict or tell the user the level of traffic on various routes. Also, it has to be able to recommend the most efficient or most reliable route to use that will save the user's time. The challenges that we expect to face, there's data quality, because we need clear images to be able to distinguish between cars. And also we have the challenge of bad weather. And also we have the challenge of even getting the data itself, because we need quite a number of data. Maybe to add on onto our project, we are using Bing aerial imagery to generate which can offer, there are many websites that can offer real-time imagery for this, to achieve this. So one of them is Bing Aerial Imagery, which shall be using, or Google Maps, Google-based imagery. They offer real-time imagery that